Hello everyone, my name is K. Harika, working as Assistant Professor in the Department of Computer Science and Engineering in Marri Laxman Reddy Institute of Technology and Management. Today I am going to discuss about CPU scheduling algorithm. Here, four types of CPU scheduling algorithms are there. One is first come first serve FCFS scheduling algorithm and shortest job first scheduling algorithm, priority scheduling, and round robin scheduling algorithm. These are the four types of CPU scheduling algorithms. When coming to first scheduling algorithm, that is first come first serve algorithm. That is in the name itself it is there. First come first serve means which process is comes for the execution first, then that will be executed, then after it will exit from the CPU, then next process will enter into the CPU. For example, here we have taken three processes P1, P2, P3, and here burst time is there. What is burst time? That means the time CPU taking the control of the process is called burst time. We have taken P1, P2, P3 are the processes with burst times 24, 3, 3. Suppose we are taking the order P1, P2, P3 to execute those processes in CPU. First, P1 is entered. So there is no waiting time for P1. Okay. And the burst time of P1 is 24. And next, then after completion of P1, then P2 will enter. P2 waiting time is 24, which is the burst time of previous process. That means P1. And what is the burst time of P2? 3. So 24 plus 3, 27. That is the waiting time of next process, that is P3. P3 is it is having the burst time 3. So 27 plus 3, 30. This is actually turnaround time of P3. That means completion time. Here waiting time for P1 is 0, P2 is 24, P3 is 27. And average waiting time is 0 and 24 and 27 divided by number of processes are in the execution. That means 3. So the average waiting time is 17. So this is the one of the order we have taken P1, P2, P3. For that we got average waiting time as 17 milliseconds. Okay, if we take another process, if we take another order with same processes P2, P3, P1, if we take different order, then whether it is having any difference in the average waiting time or not, we need to check. So we have taken P2, P3, P1. This is the order. And in this, once P2 is entered into the CPU, then that P2 waiting time is 0. Because before this, there is no processor in the CPU. So there is no waiting time for P2. So that is waiting time of P2 is 0. Then what is the burst time of P2 here? 3. Right. So that is the burst time of P2. P2 has completed. Next, in the order, what is there? P3. P3 will be in the execution process. So that is having waiting time is 3, which is the burst time of P2. And P3 burst time is what? 3. 3 plus 3, 6. Next, P1 burst time is what? 24. 6 plus 4, 6 plus 24, 30. So now check waiting time for P1 is here, right? Waiting time for P1 is 6. P2 is 0 and P3 is 3. Now check average waiting time of those three processes. 6 plus 0 plus 3 divided by number of processes. Those are 3. So finally we got answer as 3 milliseconds. And this order is much better than previous order. Okay. So what is the disadvantage? It is non-preemptive algorithm, which means once a process has entered into the CPU, then until its execution, there is no other process will enter into the CPU. After completion of that particular process, after completion of its execution, then it will exit from the CPU. Then only next any other process will enter into the CPU. So this is improper scheduling, because if you take taking as P1, P2, P3 order, or else P2, P3, P1, P3, P2, P1, like that, we are taking any order in FCFS. First come, first serve. If P1 is entered, then it will complete its execution, then only P2 will enter. Like that, if we take any order, we follow the first come, first serve method. So based on the order, we are getting average waiting time. So that is a improper process scheduling. By using this FCFS scheduling, we are in this resource utilization in parallel is not possible. That means it leads convoy effect, which means whole OS slows down due to few slow processes. For example, in this we have taken P1 as 24. This is 24 burst time. This is 3. This is 3. So P1 is taking much time when compared to other processes to execute. So it is taking much time. Then this process 2 and process 3 will have will get slow in execution. So by this condition, OS will slow down. Then that is nothing but convoy effect. Hence, the poor resource utilization will be there. So what is next one? Shortest job first scheduling, SJF scheduling. That means in the name itself it is there, shortest job first. Which process is having less time to execute, that will select by the CPU first. So it sells the waiting process with the smallest execution. That means burst time, which is having the less burst time, that will be selected first by the CPU. See, here for example, we have taken 4 processes and their burst times. P1 has 6, 8, 7, 3. These 4 processes are having these different burst times. Here, which is having less burst time here? 3, which is of process P4. That will be entered into the CPU first. Then next P4 has entered. Okay. Then next less time is what? 6. P1 will enter into the CPU. Then next P3. P3 will enter. Next P2. That is having 8. Then that will be entered next later. So here What is the waiting time of P4? 0. P1 3. P3 9. P2 16. Then what is the average waiting time? All these waiting times divided by number of processes. Here we have taken 4 processes. So divided by 4. Now you will get 7 milliseconds. Okay, fine. This is the best scheduling algorithm. But what is the disadvantage here? Before entering into the CPU, any process before entering into the CPU must know the burst time of each process. Then only it can choose particular shortest burst time. Which process is having shortest burst time, that will be chosen by CPU. So that is the disadvantage, because here the job must be known before execution. Before entering into the CPU itself, it should know the burst time of each processes. That is the disadvantage. Next, priority scheduling. Here also, in the name itself, it is there. Priority. Based on the priority, the processes will choose and the process will enter into the CPU for the execution. So here, either that process can be preemptive or non-preemptive, whatever, but it will choose based on priority. So here, what is the problem here? Starvation. That means low priority processes may never execute. Then what is the solution for this? Aging. As time progresses, increase the priority of the process. So here, based on low priority, if one process is having low priority, then that may never execute. So for that, as time progresses, it increases the priority of the process. For example, here we have taken 5 processes, and here burst time of their processes, and here we have included priorities. So first we have given first priority for P2, then second for P5, third P1, fourth P3, fifth P4. Based on the priority, the CPU is taking the process for the execution. That means which process is having more priority, first priority, highest priority, that process will enter first. So here, first priority is having P2, that is entered into the CPU first. Then it is having burst time is what? 1. Here it is 1. And next priority is what? P5. P5 will enter into the CPU now. So P5 has entered. What is the burst time for this? 5. 1 plus 5, that is 6. Next priority 3. P1. P1 will enter. And it is having burst time 10 plus 10, 16. Next priority is what? P3. P3 will enter, and it has burst time 2. 16 plus 2, 18. And next P4, that is last and least priority. That is P4, which is having burst time as 1. Okay, these are the waiting times of here P1. What is P1 waiting time? 6. P1 waiting time is 6. P1 waiting time 6, P2 waiting time is 0, P3 waiting time 16, P4 waiting time 18, and last P5 waiting time 1. So average waiting time is all these waiting times and divided by number of processes. That means 5 processes we have taken divided by 5. Finally, we got answer as 8.2 milliseconds. Based on the priority. In this scheduling, based on the priority, the CPU will give the priority to the particular process. Based on the priority, the process will enter into the CPU for the execution purpose. Next and last one is round robin scheduling algorithm. Round robin scheduling algorithm means it follows the FIFO manner. It follows the FIFO manner, but it is given some limited amount of time. That is nothing but time quantum or time slice. Time quantum or time slice. If a process does not complete before its CPU time expires, before this time quantum expires, the CPU is preempted and it is giving the chance to the next process which is waiting in queue. Let's see as an example. Here we have taken 4 processes and burst time. See, and here we are giving time quantum. Time quantum is 20. Okay, first P1 has entered into the CPU. P1 is having burst time 53, but the time slice is having 20, only 20. So 53 minus 20, that means 33. Here P1 is having time quantum 20. Within the time slice, within the time quantum, the P1 is not executed. So that the CPU will jump to next. It will give the chance to the next process which is in waiting queue. So next process P2, it will come to process P2. Within the time quantum is 20. Within the time quantum, it will be executed. So less than 20, it is there, burst time. So this will be executed here itself. So P2 has executed. Okay. Next, it will go to P3. P3 is having burst time 68, but the time quantum is 20. Minus 20. Now remaining burst time is 48. Again, it will go to next process P4. Within the time quantum is not there. Time quantum is 20, but it is having 24 as burst time. Minus 20. Now remaining burst time is 4. Is there any next process here? P5? No, right? So it will go again from the starting process. This is nothing but round robin. So again it will check the process P1. Again, now the burst time of P1 is partially executed right here. So remaining burst time is what? 33 minus 20. What is remaining? 13. This is the remaining burst time. So P1 has entered again, and here within the time slice again partially executed. Remaining burst time is there. So it will come again for P2. P2 already executed, right? So it will go to next process P3. It is having burst time 48 minus What is time slice here? 20 milliseconds. So minus 20 milliseconds, 28. Remaining burst time is 28. What is it? P3. Then it will go to P4 again. P4 having burst time 4. Within the time slice, it will be executed here. Here P4 is executed. Okay. Again it will go to initial position, means first process. P1 is executed or not? No, right? Still we have some burst time. This is P1, remaining burst time is 13. Within the time slice it is there. So it has executed here. P1 is executed here. Then it will go to P2. Already it executed. So it will check P3. It is not executed. What is the time slice or time quantum? 20. So within the time quantum, it is not executed. Somewhat it is there. Remaining burst time is 8. Again it will check P4. P4 already executed. Then it will come again. P1 executed, P2 executed, P3 not executed, right? Within the time slice, it will execute here and come to P4. It is executed. So P1, P2, P3, P4 all are executed in the CPU and exit from the CPU. So this is the actually this is typical process, but higher it is having higher average turnaround than SJF, but better response because it is giving the chance to next processes also. These are the 4 different types of CPU scheduling algorithms. Thank you.